So now we come to parallel circuit. So got basically the three resistors here again. So you can just take the series circuit and copy it. And so you have the series circuit still around. And I've taken off all the jumpers. I have the power supply going to these rails. So this one is pretty sweet because this is the real strength of this system. So we just go from the rail. See, that resistor is now connected. And now, so that's R1. So R1 is now connected to the battery and to the return. And let's try, I want to just show you something. So these all three now are connected to the return. Now, I'll remind you that I'm using different resistor values than yours. So you shouldn't write down what you see here because it's going to be different when you do it. Okay, so we see that we have some current flowing. So we have at least one circuit. And I don't think that one can, no, I have to stop the simulation. So now I'm going to add in another resistor. So now there's two in parallel. And we see that the current is higher. It was 30 something, now it's 53. So it's going to go from 53. Let's see, we'll add one more yet. And so look at that. So we see that there's multiple current paths means that the total current isn't greater than if I had a single current path. Adding current paths means that we have a greater total. All right, so we see that there's only one voltage measurement here. So I am going to leave that one to you guys to figure out. You need to use the digital voltmeter, and you need to, once again, you see how I have the schematic to refer to. That's really important. I have that all the time to double check. So it'd be nice to put a voltmeter here. And then, because it's very straightforward to do this, you can disconnect it and reconnect it here, and disconnect it and reconnect it here. Or if it's a little more intuitive, I'll show you a different way to do it. Let's get rid of this. Okay, so we got the power supply, and now we have the R1, and we have R2, and we have R3. So it's instructive to measure all three of those places and be absolutely certain that you get what you think you're supposed to get. And so there's only one place to put a voltage, so there's a hint right there. Okay, so now we want to measure currents, huh? So let's get this back up here. And so let's get rid of voltmeters. Although, in principle, we could leave a voltmeter connected here. So we want to measure the current in 4 different places. So this is going to require us to, you see, 1, 2, 3, 4 current measurements that we need. So this one would be I total, also known as I123. This is going to be I1. It's going to be I2. This is going to be I3. All right. So let's go ahead and I'm going to measure I2 for the fun of it. So that means we have to break the circuit. And so we're going to go from, now we could go over here, but this is the power of the rail. So we can just go from the positive rail over to the ammeter. And then we go back from the ammeter and we just now go into R2. So we pass it through the ammeter first. That would be now up here. That would be here. Oops, what's going on? So let's take a look. We start and all right. You won't even see it. Here we go. So I don't have the voltmeter connected because I said that was your job. All right, so I see for I2, 20 milliamps. So that would be 20 E minus 3. And it's 3 sig figs, 20.0. And the plus minus, oh, in scale is not applicable. And the error is going to be in the hundredths place because this is the tenths place. So it's going to be 0.05 times 10 to the minus 3. 0.05 E minus 3. All right, so you can just go ahead here and finish filling this out.